In addition to standards-based Yang models like those from the IETF, we can also use Cisco-specific models to manage our devices. To those who attempted the challenge, I hope you explore the Yang models first to get a general idea of how to form your data. Let's check out the MakeTrees bash script, which simplifies the usage of PyYang. We only need to explore one Yang model when it comes to VLAN management. We've gone through the PyYang commands many times, so I won't dwell on that. Note that we will be saving output to a text file for this specific iOS XE version in the data.ref directory. Let's run the MakeTrees script to generate the tree representation of the Yang model. Let's ensure the file was created. Okay, looks good to me, so let's dig into this iOS XE VLAN text file. To configure VLANs, we need to find the VLAN list. It's contained under the iOS native and VLAN URL, so let's jump down to it. The key of the list is the VLAN ID, which is an unsigned 16-bit integer. The network engineers out there know that VLAN IDs only go from 1 to 4094, not 0 to 65535. Checking the Yang model, we can see that a range constraint has been applied to ensure only valid VLANs are entered. We discussed this in greater detail in a previous course, but I wanted to refresh your memory. Yang gives us the power not only to describe data structures and types, but also acceptable values. We can also specify a VLAN name, which is quite common, but this is optional. Now that we've seen the Yang structure, let's check out the Ansible setup. It's quite similar to the previous demo on interface management, so I'll focus on the changes. Let's begin with the Ansible config file. This file is identical between both projects. We still use host.yaml for our inventory, we still don't want to collect system facts, and we still want to ensure Ansible is using the correct version of Python. Let's move on. Next, let's open host.yaml, which is our YAML formatted Ansible inventory. To be more technically accurate, I've renamed the group to RESTconf switches from RESTconf routers, and we have a single host named cat9300. We set the Ansible host to the IP specified in the sandbox instructions. When we connected to the always-on sandboxes, we used globally resolvable host names. We don't have that in the sandbox. We are telling Ansible to use the host name cat9300, but Ansible should connect to 10.10.20.100 rather than interpreting cat9300 literally. Last, let's check out our group variables file. This contains our connectivity and infrastructure config parameters. The connectivity parameters are almost identical, except that the RESTconf port changes from 9443 to regular 443. This isn't terribly relevant, but be sure to check your specific sandbox to see how the ports are set up. Scrolling down, we see our infrastructure parameters, which will be used for addition and deletion in the next clip. Per the Yang model, we need to define a VLAN list, and we must specify the ID as an integer between 1 and 4094, which we did. We can optionally specify a name, and I'm defining a data, voice, and management VLAN, each with a unique ID. The new VLANs dictionary gives us access to this entire Yang structure to minimize data modifications in the playbook itself. In the next clip, we'll explore VLAN collection, addition, and deletion using 3 separate playbooks.